So we are transmitting a single sine wave signal, and we can view it in the spectrum domain. The signal was transmitted by another computer, and we use the USRP2 FFT display to view it. And we can see that the signal was transmitted by 2.48 gigahertz, and it's very clear. And we can also view it in the time domain.
No, not the mouse.
No mouse. Oh, yeah. And we can view it in the time domain, just change the opacity. And it's a sinusoidal wave. Yeah, you can change the amplitude. This one? That one? Yeah, if you change it, you can see it more clearly, and that's sound. That's a very simple example, and my friend Tan will give you some instruction on the software.
Now I will talk to you about the software to use the for the USRP2. In order to use the USRP and also the USRP2, we need a software installed on in the computer. Here we use the GNU radio. The GNU radios is built up from the Python and the C++, in which the C++ is used to build up the signal processing blocks, and then the Python is used to connect the blocks together in order to form the program or the software to process the data that you receive from the USRP2. Yeah. So it means that in the GNU radio, the Python only used to connect all the blocks from the C++, and if you want to make your own signal processing blocks, you have to deal with the C++. And right now, I can guide you how to install the GNU radio on a computer. The first step is go to this link and get started. To get started, and then we install all the prerequisites in this website. It depends on the version of your Ubuntu. Then you will have the proper prerequisite for the GNU radio you want. Here we use the Ubuntu 10.10. It means that we have to install the prerequisite for the Ubuntu for the GNU radio with the Ubuntu 10.10. After install the prerequisites, then we download the GNU radio code from the website, and then configure, compile, and install the GNU Radio on your desired folder. Here, in our case, we install the GNU Radio in the home folder, and we install the GNU Radio 3.2.2, as you can see on the screen. Now let's come to the first exam. I will use the GNU Radio to create two sinusoid source. The first one with the frequency 420 Hz, the second one is 640 Hz, and then add them together, and then I will send them out to the FFT, to the oscilloscope, and to the speaker. Here's our code. The first line of the code means that you can use the Python to execute the code, and after this is the GNU Radio copyright, and then here this part of the code is used to import the library that you need for the code to run, and then this is the part that we process the signal, connect them together and make it run. Here I create the class top block. That I import the library std-top-block, help you to run help you to connect to the program. And with the def init here, you create all the parameters that you need to use the program. Here, as you can see. And then this part of the signal that get all the parameters that the user enter into the terminal. After get all the parameters that the user input into the terminal, we will check this part of the code. We check for if we have any syntax, any error, and then if the length of the argument that the user input into the system is different from 0, it means that all you get from the parameter. After getting all the parameters from the user's command, you have the command that with the length different from 0, the system will raise the alarm to show you that it has an error in the command, and it exits the system. After getting all the parameters from the user, then we define the amplitude of the signal. Here is I set to 0.1, and here I want to display it on the FFT, and then the oscilloscope. This part I define the source. The first source is a sinusoid waveform with a frequency 440 Hz, and the amplitude, as you can see here, 0.1. The source 2 also the sinusoid waveform with the frequency 640 hertz, 640 hertz with amplitude 0.1, and we add two source to the source. It means that here we have the add. Here, this is the adder. As you can see, the source 0 here, source 1 here, and you add them into the adder. Here, I add them into the adder. And here I use the I put them the audio, I connect them with the audio output. Before that, I put the throttle in order for the data stream to be stable. And then I connect them, the source with the throttle, and the throttle with the DSD. It means that the audio sync. And then connect the throttle with the FFT and the throttle with the scope. The function of throttle is make the data be stable. And then after define the connection of the data flow, define the structure of the data, all the connection of the blocks, then I run the main program. In the main program, I call the stdguide2.stdapp, my top block here, as you can see here. And then I go straight to the main block. Yeah, that's all. Now I will run the program.